All right, so today we're going to go on a little bit of an archaeological dig, but not in the dirt. We're digging into Bitcoin's code. We're on the hunt for this really fascinating, super ambitious feature that was there right from the start, but now it's almost completely forgotten.
I mean, what if I told you that a mechanism designed for high-speed, off-chain payments, basically a precursor to modern systems like the Lightning Network, still exists as a ghost in the machine? It's like a fossil embedded in the data of every single transaction. And wow, does it tell a story.
So to find this ghost, right, we've got to know where to look. And that means we need to take a quick peek at the basic anatomy of a Bitcoin transaction, and specifically its inputs.
You see, a Bitcoin transaction, it's not some perfectly clean modern skyscraper. It's way more like an ancient city, with new stuff built right on top of old crumbling foundations. A lot of its parts, like the input script, are just remnants of older designs, clues to Bitcoin's past. But we are hunting for something even more specific. And that's what brings us right to the artifact we're hunting for, a little piece of data called the sequence field.
Okay, so get this. Every single time a transaction is made, these 4 little bytes get tacked onto each input. Nowadays, we use them for things like time locks, making sure a transaction can't be spent for a while. But that's not what they were meant for. Not even close. Their original purpose was, well, it was way more radical. This field is the ghost of a much, much grander idea.
And that's the big question, isn't it? What was this grand vision? Why would you build something so fundamental into the code right from the start, only to just turn it off? Well, the answer? It's a story. So to really get what was going on, let's picture this. We've got 2 people, we'll call them Alice and Bob, and they want to play some cards. And they want to bet Bitcoin on every single hand. Now you can imagine broadcasting a new transaction on-chain after every hand. That'd be super slow, not to mention expensive. They needed a smarter way to do it.
So here's the genius way they use that sequence field. First up, they lock their money into a shared pot, a multi-sig address, so they both have to sign off to spend it. Then, and this is the clever part, they create a refund transaction with sequence number 0. Think of it like an escape hatch, but they don't broadcast it, they just hold on to it. Okay, so now the game starts. Let's say Alice wins a hand. They create a new transaction, this time with sequence number 1 that gives her a bigger slice of the pot. They both sign it, but again, they don't broadcast it. Then Bob wins. They create another version, sequence number 2. And they just keep doing this, updating the balances with a higher sequence number each time. And only when the game is totally over, they create one last final transaction, give it the highest possible sequence number, and that's the only one they actually send out to the network.
You see the logic here? The whole system was built on one simple rule. The transaction with the highest sequence number wins. The idea was that every node, every miner on the network, if they saw 2 versions of the same transaction, they were supposed to just toss out the one with the lower number. It made the old versions replaceable.
So what Alice and Bob were doing, this wasn't just some clever little hack for a card game. No way. This was the prototype for something way, way bigger. This was basically Bitcoin's very first payment channel.
Yeah, today we have a name for this, a payment channel. It's this idea that 2 people can send money back and forth a million times, totally off-chain, and then only broadcast the final score, the final balance, to the main network. This is literally the foundation for how things like the Lightning Network work today.
And believe me, this was no accident. Bitcoin's creators specifically talked about this. They called it a way to do high-frequency transactions. So the vision for scaling Bitcoin, it was baked right into the DNA of the protocol from the very beginning, hiding inside that tiny 4-byte sequence field. Okay, so that raises the obvious question, right? If this was such a brilliant, forward-thinking idea, a native payment channel system built right into Bitcoin, why on earth did we abandon it? Why is it just a ghost now? Well, as it turns out, the idea was brilliant, but the execution, let's just say it had some pretty massive, even fatal flaws. Let's break down what went wrong. Okay, so there were 3 big issues. First off, this whole replace the old transaction thing, it was just a suggestion, a policy. It wasn't a hard consensus rule. A miner could just ignore it and confirm an older transaction if they felt like it. No real incentive not to. Second, it was basically a game of chance. Imagine Bob broadcasts his older transaction where he was winning just seconds before Alice broadcasts the final correct one. His might get picked up by a miner first, just by pure luck. and boom, he steals the money. A secure system can't depend on luck. But really, it was the third problem that was the absolute deal breaker. So an attacker could use this replacement rule to launch a massive denial-of-service attack. Think about it. For almost no cost, they could just flood the network with thousands of replacement transactions every minute, and every single node would have to process and pass them along. We're talking about a single attacker being able to suck up about 10 gigabytes of network bandwidth every single minute. It was a wide-open invitation to just completely cripple the whole system.
Yeah, faced with a vulnerability that catastrophic, the developers, they really had no choice. The original purpose of the sequence field, this beautiful, elegant system for high-frequency payments, had to be shut down. They just switched it off in an early software update.
And just like that, the grand journey of the sequence field was, well, kinda over. It went from being this engine for a really visionary scaling solution to what it is today, a ghost feature. It's just a remnant of a protocol that got disabled. We've repurposed it for other things now, but it's still there. A constant reminder of an idea that was probably just way ahead of its time.
And that kind of leaves us with one last thing to think about. The original idea failed, right? But the concept, the core idea of payment channels, it didn't die. It was reborn years later in much stronger, more secure systems. So it makes you wonder, when a really good idea fails just because the first design was flawed, is it ever really gone? Or is it just kind of waiting in the code like a ghost for the next generation to come along and finally get it right?